Hello. This lesson is 5.5, and we're going to be talking about systems of inequalities. So we're going to start with linear inequalities in two variables and their solutions. So we know that equations in the form ax plus by equals c are straight lines when graphed. And now if we change the symbol equal to less than greater than or equal to, or less than and equal to, we obtain a linear inequality in two variables. Um, so it would look like, oops, ax plus by is less than c. That would be a linear inequality in two variables. So a solution of an inequality in two variables, x and y, is an ordered pair of real numbers with the following property. So when the x coordinate is substituted for x and the y coordinate is substituted for y in the inequality, we obtain a true statement. Each ordered pair solution is said to satisfy the inequality. So graphing, or the graph of a linear inequality in two variables, is the set of all points whose coordinates satisfy the inequality. A half plane is the set of all the points on one side of a line. So let's look at the steps for graphing a linear inequality in two variables. So we're going to replace the inequality symbol with an equal sign and graph the corresponding linear equation. We're drawing a solid line if the original inequality contains a less than and equal to or greater than and equal to symbol. We're going to draw a dashed line if the original inequality contains a less than or greater than symbol. Step number 2 is choose a test point from one of the half planes. So do not choose a point on the line. Substitute the coordinates of the test point into the inequality. And then step number 3, if a true statement results, shade the half plane containing this point. If a false statement results, shade the half plane not containing this test point. All right, so we have an inequality here. 4x minus 2y is greater than or equal to 8. The first thing I like to do is make sure that when I'm drawing the line, I'm drawing the correct, either a solid or a dashed. Now, this has the equal sign, so the line is going to be a solid line. I'm marking it so that I remember when I start graphing. So our first step was to replace the inequality symbol with an equal sign. So 4x minus 2y equals 8. And now the next thing we're going to do is we're going to go ahead and graph this line. Now, there's a couple of ways for us to graph it. Let me do the coordinate plane now first. Okay, so we're going to go ahead and find the x and the y-intercept for this. So we're going to start by substituting 0 for x. So we're finding the y-intercept first. So 4 times 0 minus 2y equals 8. 4 times 0 is 0. We're going to divide by negative 2. We get y equals negative 4. So our y-intercept is 0, negative 4 right here. Then we're going to find the x-intercept by setting y to equal 0. So 4x minus 2 times 0 equals 8. 4x equals 8, divide by 4, and we get 2. So 2, 0 is our, um, so this is point 0, -4, and this is point 2, 0. And again, it is a solid line. Let me see if I can get the ruler to work. Here we go. Makes it a little bit easier. So we're graphing a solid line here that keeps going and going. Now, our next step is to choose the test point. And when we're choosing a test point, we want to choose the point that is easiest and that is not on the line. So the point that normally is easy is 0, 0 because it's just easy to do the calculations. So we're going to go ahead and plug in 0, 0 um, to the original equation, or inequality, I'm sorry. So 0, 0, we're going to do 4 times 0 minus 2 times 0 is greater than or equal to 8. Well, 4 times 0 minus 2 times 0, it's going to be 0 is greater than or equal to 8. This is false. 0 is not greater than 8. So we know that the half plane is not on the side where the 0, 0 is. We are going to be shading the opposite side. So it's this side where it is. And we could always go and double check. Pick a point again from this side, for example, 4, 0. So if we pick the point 4, 0 and plug it into the inequality, we can see that we get 16 is greater than or equal to 8, which is true. So that's it. Now we shaded the correct side. Okay, next, graphing linear inequalities without using test points. Um, we're going to look at a couple of special cases, I guess. So vertical line is x equals a, and then we'll have a horizontal line that is y equals b. Okay, let's look at the vertical line first. I'm gonna, there's the coordinate plane, and then here's our x equals a. I'm gonna go ahead and do the same thing here. So this is y equals b. Okay, so if x is greater than a, shade the half plane to the right of x equals a. So that means that we would be shading it over here. This is x is greater than a. If x is less than a, shade the half plane to the left of x equals a. So this side right here would be x is less than a. Okay, for the horizontal line, if y is greater than b, shade the half plane above y equals b because the values are greater over here. So this is y is greater than b, greater than. If y is less than b, shade the half plane below y equals b, right here. Okay, next one, graphing inequalities without using test points. So we've got two inequalities here. We have y is greater than 1, and we've got x is less than or equal to negative 2. So let's look at first the y is greater than 1. Now, it does not have the equal sign under, so the line under, which means that it's going to be a dashed line when we graph y equals 1. Um, I did not do the 4, negative 1, negative 2, negative 3, and negative 4. Now, it says that y is greater than 1, so that means that we will be shading everything that is above. Okay, now we're going to look at x is less than or equal to negative 2. So it's equal to, that means that we're going to have a straight line going through x equals negative 2. And then it's less than, so we're shading this side right here to the left because that's where the smaller numbers are. Okay, next thing that we're going to look at is graphing a nonlinear inequality in two variables. So we have x squared plus y squared is greater than or equal to 16. So we're going to start with step 1, replace the inequality symbol by equals to, and graph the nonlinear equation. So x squared plus y squared equals 16. Well, this, when we graph, gives us a circle. The center is at origin because we don't have anything with the x and the y, and the radius is square root of 16, which is 4. Okay, so let's look at graphing it, or actually I should say sketching it, because a circle is not the easiest thing to draw. Okay, so radius was 4, so we know that we're gonna go through these points with origin being a 0. And it is a solid line because it has that equal sign. So, and now my grid is not. That's good enough for a sketch. Okay, next we're going to choose a test point from one of the half planes and not from the circle. Now, again, same thing applies. 0, 0 is an easy point right here, which is not on the circle. So I'm just going to pick 0, 0 and plug it in. 0 squared plus 0 squared is greater than or equal to 16. Well, no, it is not. So we're going to shade the region that does not have the 0.00. So it's going to be all of this here outside of the circle, like that. Okay, let's look at an application here. If X represents the age of a child and the Y represents the awake heart rate in beats per minute, the normal heart rate region can be described by the following system of linear equations right here. Show that point B, 690, is a solution of the system of inequalities that describes normal awake heart rate. So we're going to go ahead and plug it in. We're first going to take the first equation here. I'm sorry, inequality. X plus Y is greater than or equal to 70. So plugging in 690, 6 plus 90 is greater than 70. 60, hold on, what is it? 96 is greater than 70. That is true. Then we're going to test the second equation, inequality as well. So 2.6 times 6 plus 90 is less than or equal to 115. We get 105.6 is less than or equal to 115. This is true. So we know that 690 is, the 0.690 is a solution to the system of inequalities. Okay, next thing we're going to do is graphing systems of linear inequalities. So now we've only been graphing one inequality at a time. Now we're going to do a system. So the solution set of a system of linear inequalities in two variables is the set of all ordered pairs that satisfy each inequality in the system. Thus, to graph a system of inequalities in two variables, begin by graphing each individual inequality in the same rectangular coordinate system. Then find the region, if there is one, that is common to every graph in the system. And this region of intersection gives a picture of the system's solution set. Okay, so we have the system here of two inequalities. We need to graph both of these on a rectangular coordinate system. Negative, -2, -3, -4. That's a negative. 1, 2, 3, 4. -1, -2, -3, -4. Okay. We're going to start with the first one here. So x minus 3y equals 6. This is going to be a dashed line because it does not have the equal sign. Now, there's a couple of ways, and we can find the x and y intercepts again like we did before. Or what we can do is we can use the slope intercept form to graph it. So what I'm going to do instead here is I'm going to solve for y. So I'm subtracting x from both sides to move it. -3y equals -x plus 6. And then I need to divide by -3. So I get y equals 1/3 x minus 2. 1/3, or actually, -2, this is my y-intercept. So it's going to be 0, -2 right here. Slope is 1/3. So remember, slope is rise over run. So I'm going to go ahead and it's a positive. So I know it's going up to the right. So I'm going to go 1 up and 1, 2, 3 to the right. Or I'm going to go 1 down and 1, 2, 3 to the left, right here. And now I'm going to graph the dashed line here like this. Next, I need to figure out the test point. Which way am I going to be shading for this one? So what I'm going to do is I'm going to try to plug in the point 0, 0 because that's over here and that's an easy one. So 0 minus 3 times 0 is less than 6. Well, 0 is less than 6. So for this one, I'm shading where 0, 0 is, so on the top here. And I make sure that you don't shade too dark yet, because we're going to shade the other one as well. Okay, now we're going to take the second equation and do the same thing. 2x plus 3y equals negative 6. This is going to be a solid line. We're subtracting 2x from both sides, so we get 3y equals negative 2x minus 6. Divide by 3, and we get y equals negative 2/3 x minus 2. So again, our y-intercept is 0, negative 2, so the same. But now our slope is negative 2/3. So it's actually going down 2 and 3 to the right. Or we're going up 2 and 3 to the left. It's a solid line, so I'm going to go ahead and sketch the line here. Now I need to figure out which side am I shading. So I'm going to use, again, the point 0, 0 here. So 2 times 0 plus 3 times 0 is greater than or equal to 6. 0 is greater than or equal to 6. That is false. This one was true. So we are shading the other side from where the 0, 0 is. So we're shading this side right here. Hold on. I made a mistake here. That's not correct. I'm missing something here. Okay, now I'm missing part of this right here. Okay, I'm missing a negative here. So this is true. 0 is greater than negative 6. So this is the part that we're shading. So now our solution for the system is going to be the part that is shaded by both. So it's going to be here above both lines. You've got to be careful that you're not shading anything extra. But that would be the part that is our solution right here. Okay, let's look at this next one. We need a coordinate system again. 1, 2, 3, 4. 1, 2, 3, 4. Those are negatives. These are positives. And negatives again. So y is greater than or equal to x squared minus 4. We're going to set that to equal. And again, this is going to be a solid line because it has that equal sign. Actually, both of these are going to be solid. Okay, y equals x squared minus 4. That is a quadratic equation. So we know that our vertex is going to be right here, 0, -4, and then it's going to come up um, something like this. Now, and again, you can plot points if you can't remember how to do it. We could do a table and, you know, do 0, y equals x squared minus 4. I mean, this is x. So 0, um, y is going to be 0 squared minus 4, which is -4, which we just plotted. Then we've got 1 squared minus 4 is going to be -3. 2 is going to be 2 squared minus 4, which is 0. So that's where the 2, 0 comes from. And these points are on the same, because it's symmetric, on the same side. Okay, but now we need to figure out, for example, we're going to, again, we can use 0, 0 as the test point because it's not on the line. So 0 is greater than or equal to 0 squared minus 4. Well, yes, 0 is greater than -4. This is true. So we know that for this one, we're shading the inside right here. Okay, let's go ahead and take the second one, which is x plus y is less than or equal to 2. Again, this one's a solid as well. X plus y equals 2. So y equals -x plus 2. Y-intercept is 2. We're going downhill because it's a negative. So we're going down 1 and to the right 1. Down 1 and to the right 1. And again, a solid line. Something like this. Now we can still use the 0, 0 as a test point. So 0, 0. 0 plus 0 is less than or equal to 2. Yes, that is true. So we are shading the side where the 0, 0 is. So now we can see that this area here is the solution to this system, because that's the part that is shaded by both. Okay, that's it for this lesson. Let me know if you've got any questions. Bye.